next-gen single-page application compiler written in Common Lisp devlog 2. I have two topics for this video: keep state and dynamic lists. Keep state is very simple. When you create a component and you, for example, type something, when you recompile that component, the state is lost. So to remedy that, I added a new flag, keep state, true. If you now type something and you reload it, the state is being kept. Now, obviously, if you want to remove it, just disable this flag. By default, it's false, so you can either keep it, set it to false, or just turn it off. Just comment it out. And now the state is being lost again. And that's it. So the next subject is dynamic lists. Now, dynamic lists is a big subject, and I have so far implemented only a small portion of it. And I will talk about it more at the end of this video. So let's create a simple static component with a list of elements. Here's the list. This is the syntax. It's similar to Common Lisp do list syntax. Here's the element name, here's the list name, and here is the body. And in reality, this macro creates a component which looks exactly as if you wrote it using this syntax, def component. And it splices this code into the generated code of the parent component. There is one problem with it that I have a solution for, that I will also talk about later, is that dynamic list must be the only child of a given parent element. If there are other elements either before it or after it, the code will throw errors. And yeah, I will talk about that later. So let's add the onClick handler. And now this is the change. pschain is just a stupid syntax from parent script that means IDs dot push parentheses, and then we push a randomly generated number from 0 to 9, I believe. And setF, I will talk about that in a few moments. This is like in Svelte.js, where you have to add an assignment to make it reactive, because just this will not trigger the lifecycle call in this component. So let's do it. Now every time I click, a number is being added, and the way it works is, if you look at it, it looks as if only this new element was added. However, the entire list is being re-rendered every time we do it. Why? Because I haven't implemented single element mutations for arrays, sets, maps, and so on. I will, however, and I have a plan for it. I will also talk about it at the end of this video. So with that, so let's duplicate this field set, and now there are two copies, and they use the same IDs list. So predictably, if you click on one of them, the other, subtree will also see the changes. We can create two separate lists, obviously, so that each subtree uses their own list. And if you do that, the other list doesn't see this list changes, and vice versa. And that's it. Yeah, this is what the component looks like. So this is one component. This is the code that you would write in Common Lisp, and this is the code that is generated for you. All of it. This is the new compilation here. Yeah, so this is the component generated code. And there is a problem here that I will solve in the future. Namely, if you look at these inline dynamic list, they use the same shape of this tree. And in the future, I want the compiler to figure out for you that it can create one component, put it outside of the parent component, so that the constructor or the component function is reused across all components to avoid creating a new function in every instance. And there is another problem. Right now, this is a component, and the question is, why would you create an entire closure for one element? And you wouldn't, but at the moment this is how it's done. So in the future I want to implement such 3 functions for every such dynamic list. Create, that just returns a new element of a given tag. Patch, that takes some data and patches an already existing node or a newly created one. And destroy, which removes some on-click handlers to avoid memory leaks. And so I wanted to talk about the mutations for arrays or sets or maps and so on. So the way I want to do it is when the compiler notices that you just want to add one element to a given list, instead of doing it like here, that you push one element to the list and then you write the entire list as a new value for that list, it would do something like this. Lifecycle write, and instead of just num or IDs2, it would do IDs _2 colon push start or colon push end. So this would pass only the one new list item instead of the entire list, which would be a lot faster. And that is it. That is everything I have for this video. So thank you for watching. Leave a comment or ask a question, message me either here or on Twitter, and see you in the next one.